Algebra 2, Chapter 5.4, exercises 13 through 20. This is the exercise set that has to do with systems of linear inequalities. I'm going to, in this video lesson, go over the odd number problems 13, 15, 17, and 19. In 13 through 16, we have these graphs of linear inequalities, systems of linear inequalities, and the idea is to take from these graphs, make formulas, I won't say equations, but actually inequalities, and so it's backwards from the exercise 1 through 12. And so for number 13, right here, we're going to look at this top line here, and we're going to start with y. Y is equal to, and we're shaded below, so equal to and less than. And what do we put in there for that? Well, first of all, we look at the y-intercept, which is at 2. So at the very end here, I'm going to put plus 2. And now we need to find the slope. And to find the slope, we go to rise over run. Well, we're going down. And here, from this y-intercept of 2, we're going down to 0. So that's going to be -2. And then to the right, we go 4 units. And so our slope is going to be -2 over 4, which reduces to -1/2. And so our inequality ends up being y is equal to less than -1/2 x plus 2. And that's going to be this one right here. Okay, the next one we're going to look at is this dashed line, and I'm going to change colors here and go to red. And we go to a y-intercept of our dashed line of -4, but first I'm going to start out writing is y, and we are above, so not equal to, but greater than. We have -4 as our y-intercept. I put that at the very right. And now going up, we're going to go up 4, so plus 4, and to the right 2 units, 2, so our slope in this instance is going to be m equals 4 over 2, or 2. So we get y is not equal to, but greater than 2x minus 4. So these would be our two inequalities that constitute the system of inequalities that comprises the graph shown. Next, what I'm going to work here is problem 15, and we have, looks like, two parallel lines. So I'm going to take the top one first, and I'm going to put y. And it looks like we are shading below, because in order to get this gray area between the two parallel lines, we have to be going in opposite directions. So y is not equal to, but less than. And what is our y-intercept here? Well, it's going to be 4. So at the very end, I'm going to put plus 4. And then as far as what the slope is, looks like we have a negative slope. So we're going to go this boundary line down 2, and then to the right, looks like we're going right 6 units. So our m is going to be -2 over 6, which simplifies to reduce to -1/3. So we have y is not equal to but less than negative 1/3 x plus 4. And then for our boundary line below, switch colors again, we have y is not equal to and not equal to, but actually greater than, because we are going to be shading in up direction from this lower boundary line. So y is not equal to but greater than, and our y-intercept here is -2. So I'm going to put -2 down here. And now for the slope, being parallel to the first one, we're going to have -2 and then 6. So it's going to be reduced to negative 1/3. So these would be our two inequalities represent this system, and you can just test a point within that. If we test 0, 0, we plug in 0 for x, well, then 4 is going to be certainly greater than 0. If we plug in for this lower inequality for x, 0, we are going to have -2, and -2 is certainly less than 0. So these are the two inequalities that constitute the formulas for this system. Okay, next one, we're going to go to problem 17, which is a real-world problem. We have a surf shop makes profits of $150 for each surfboard and $100 for each wakeboard. The owner sells at least 3 surfboards and at least 6 wakeboards each month. The shop owner wants to earn at least $2,000 per month. Graph all possible combinations of surfboard and wakeboard sales that would satisfy the store owner's earnings goal. Use a checkpoint to justify the reasonableness of the solution. Okay, so we have surfboards on this S-axis, which is like the X-axis, and we want to sell at least 3 surfboards. So I'm going to mark that 3. We have to have at least 3 surfboards and at least 6 wakeboards. So we know we have those constraints there. And we also know the shop owner wants to earn at least $2,000 per month. Well, we can find our x-intercept and y-intercept for the wakeboards. Our wakeboards will be $100 for each wakeboard. So if we take 2,000, which is what we have to earn, and divide that by $100, we're going to get, by canceling zeros, we get 20 wakeboards needed. So the way it looks like they're kind of going up 3, 6, 9, and between them. So they're going up like, it's going to be like 1.5 between. We want 20. So 20 is going to be about right here. So I'll put 20 right here. That's what we'll need if it's only wakeboards. And then for the surfboards, the profits are $150 for each surfboard. So if we take $2,000, which are needed, we're going to divide by 150, and then 150 goes into 200 once. We bring down this 150, and we subtract and get 50 here, and 50, and bring down this 0 here. So 150 goes into 503 times, and then we get 450 here, and then we get 50, this 0, so we get 13.3, 13 1/3. So this is going to be 12, 15, so that'll be about 13 1/3 right here. So I'll put 13 1/3. So now we're going to draw the lines that define, and we say, what does it say? At least. So we can use solid lines. I'm going to go to my tools here and get the line. I'm going to get a solid black line. And we know we have to have at least 3 surfboards. So I'm going to make this vertical line. We know we need to have at least 6 wakeboards. And we know we have to have at least $2,000 in sales, which we get that constraint by connecting our y-intercept here at 20 and going right down to the x or s axis. And so our solution set is going to be greater than 3 surfboards, so to the right of this line here, greater than 6 wakeboards, so right up here, and also to above the $2,000 line. So our shaded area is going to be this one right here. And the last thing we're going to do is take a point here to check for reasonableness of solution. So what I'm going to do is take this one right here where we have 9 surfboards and 12 wakeboards. So I'll put the coordinate pair 9, 12, and we're looking for this value to be at least $2,000. So we'll say earnings is going to be equal to 9 times our surfboards, and surfboards are $150 earning, plus 12 times $100 for each wakeboard. And so 9 times 150, let's see, 10 times 150 is $1,500, and 9 is going to be 150 less than that, so we get $1,350 plus 1,200, and that's going to be equal to $2,550, which is $2,550 is certainly greater than or equal to $2,000. So that checks out as a reasonable solution. So there it is. Next, the last one I'm going to go over here in this video lesson is 19. In 1 week, Ed can mow at most 9 lawns and rake at most 7 lawns. And so I'm going to mark here the raking at most 7 lawns. So I'm going to mark 7 right here. And then I'm going to take mow at most 9 lawns. And so 8, 10, so 9 will be right here on the mowing. So I'm going to go ahead and just put those lines in place right now for those 2 constraints. And at most, that means that's the most he can do. So I'll make this one here at 7, and this one vertical here at 9. So we are going, at most, has to be less than. So we have that direction here from the mowing line, and this direction here from the raking line. And then he needs to earn more than $120 in 1 week. So not $120, but more than. Well, to find out where our intercepts are going to be, if we take $120 and divide it by the $20 for mowing, 20 goes into 120 6 times, and that's it. So 6 mowing jobs. So we can go right here to 6, and I'm marking that right on the x-axis. And then for the raking jobs, $10. So we take 120 and divide that by 10. We get 12. So 12 raking jobs will do it. So there's 12 right there. And what we're going to do is connect these two intercepts. And we have to have at least, so we're going to go to the right of that. Let's go get our line again, tools, lines. This time we have to have greater than, so I'm going to use the dashed line in this case. And so we start here, go down to 6. So that means that we have to have above this line, which means that our constraints are going to cordon off this area. And then finally it says take a point. So if I go right here, I'm going to call this the point 8 mowing jobs and 2 raking jobs. That's going to have to be at least $120 to prove a reasonable solution. So I go back here. So earnings is going to be equal to 8 times our mowing jobs. Our mowing jobs, he's earning 20 for each one, plus 2 of our raking jobs. And we're going to get 8 times 20 is $160. And 2 times 10 is $20. That's going to be $180 total, which, since $180 is more than what he needs to earn more than, which is $120, that checks out as a reasonable solution. So this is the exercise set. I hope this has been helpful to you. Good luck in all the other problems, even more problems in this set. And thanks for viewing.